All right, let's get started with lesson 1, why do bonds form? This is the first lecture video of unit 3 under chemical bonding. And we're going to, in this very lecture video, discuss this very question. Why do bonds form to make chemical compounds? So to start out with, let's look at a definition of chemical bond. It is an electrostatic attraction or force that holds two atoms together to make a compound. Now, we've already addressed electrostatic attractions in the earlier units when we talked about states of matter, for instance, that solids and liquids both have electrostatic attractions between the particles that make up solids and liquids. But gases have zero electrostatic attraction, and so therefore they are gases. Now, we will address specifically in this unit electrostatic attractions or forces between atoms that make chemical bonds. Now, an interesting thing too is that atoms, when we link them together by bonds, have very different properties than from their parent atoms. We're going to take a moment and we're going to actually demonstrate this very idea by looking at a demonstration video on making salt or sodium chloride. All right, here we go. So this chemist here has an actual gas tube that is got chlorine gas in it, and that's that yellow gas that you see inside this glass container. He just took it out, and the container is closing the chlorine gas seal. And what he's going to do is he's going to take some sodium now out of a jar that he's going to use to react with the chlorine gas that's inside of that glass tube. Now, sodium metal is very reactive with water. So he put it into a glass container with kerosene to protect it so that it doesn't react with water and cause problems. All right. Now he's going to take the sodium and he's going to place it in a ladle, and he's going to put the ladle and the sodium into the Bunsen burner. And this is going to heat up the sodium but clean it up to make it get it all nice and purified so it reacts really well with the sodium, or with the chlorine gas that's in that glass tubing. And again, the chlorine gas is yellowish gas in there. All right. So as he's heating it up, you can see the flame test is going on there for sodium. You see the yellow flame. All right. So now he's put it into the tube. It's reacting with the chlorine gas, the sodium, highly reactive. Puts off a lot of energy. But the result of this very reaction now is to produce sodium chloride, which is just regular table salt. And the reaction, as it's diminished, all that's really left in there is now table salt. All the chlorine gas and the sodium's been converted over to salt. All right, and so that's pretty much what it is. And there's what table salt looks like. All right. So let's go back to our PowerPoint here. All right. So let's see. Get this on the screen. All right, there we go. So it's really interesting, I think, that you take sodium metal, very explosive with water, and you take chlorine gas, which is highly toxic, poisonous to us. But when we combine those two together to form a chemical bond, which results in a compound of sodium chloride or salt, that it's perfectly safe for us, and we can consume it and eat it. So again, this is a great example of the properties of the bonded atoms together are different than the individual parent atoms. Okay, so let's get into now what this whole lecture video is supposed to be about, and that is, why do chemical bonds form? Bonds are formed during chemical reactions, like we just saw, to help atoms fill their valence electron shells. Independent atoms have relatively large potential energy. Nature, however, favors arrangements in potential energy that is low. This means that most atoms are less stable existing by themselves with unfilled valence electron shells than when they are combined having full valence electron shells. So by so by bonding with each other, atoms decrease in potential energy, thereby creating more stable arrangements of matter. So the way I want you to look at this is that when atoms do not have full valence shells, they have too much potential energy. And so in order to get rid of all that potential energy, the atoms are going to then form chemical bonds that will allow them to have full valence shells. And they will be happy when they have those full valence shells and low potential energy. For instance, let's take a look at these noble gases. These noble gases, if you look closely, will have full valence shells. How do we know that? Well, to have a full valence shell, you must have either 2 valence electrons, such as helium does, or you need to have 8 valence electrons, like neon and argon and krypton and xenon and radium. Okay, so in this diagram, if we count up the electrons, you'll see that we have 8 electrons in each of these atoms' outer shells, with the exception of helium, which only needs 2 electrons in its outer shell. So the noble gases have full valence electron shells. With a full valence shell, noble gases are very stable and unreactive. All other atoms require full valence electron shells so they can react with each other to acquire this stable arrangement. In other words, one of the reasons why we call the noble gases noble is because they have achieved this very goal. They already have full valence shells. And so they're noble, they're great, and all the other elements have a desire to be like these noble gases, to have full valence shells, so that they can be happy too and have low potential energy, just like the noble gases. So the trade-off, though, is that all the other elements on the periodic table must form chemical bonds with each other in order to achieve full valence shells to become like these noble gases. All right? So that is the idea of why chemical bonds form. Again, to achieve full valence shells so that they can have stable arrangements of low potential energy. If you understand this, you're on the right track. All right? So this is it for this lecture video. Study these notes really well. Prepare for a quiz. If you need to rewatch this lecture video, do so to keep you informed on or to answer that very important question of why chemical bonds form.